to stream to Twitch right now. But okay. So if I'm going too fast at any point, just make sure to ask me to slow down, or so the question we're going over is called Atlantic water flow, and it says given an n by n matrix of non-negative integers representing the height of each unit cell in a continent, the Pacific Ocean touches the left in the top of the matrix, and the Atlantic Ocean touches the right in the bottom edges. Water can only flow in 4 directions: up, left, right, or down, or up, down, left, or right, from a cell to another one with a height equal or lower. So if 2 heights are equal, then it'll just roll on that height. So find the list of coordinates where you can flow. Will it roll? Because let's say for example, let's say we have.
Could you enlarge that, please? All right, no, that's fine. Just.
Yeah. So let's say this is a height of, so right here is 0, then it goes to 1. So if because water flows downhill, right?
Yeah.
So this line right here is kind of bad. Can I erase this? I can. So right here, so this is 2, right? So the water would flow down here, and then it would just stagnate right here because it's flat, and then it would roll down again. So basically, we're saying that if there's 2 heights that are exactly the same, then water is still going to flow down as if it were downhill to an extent.
Okay, cool.
Yeah, so that's something important to understand. So let me go over exactly how I did this problem the first time, and why it worked, but why it was a bad inclination to do so. Let's see, for my handwriting is not the best, but we'll see how this works. 3, 1, 6, 7.
I'll try not to.
What's up?
I said I'll try not to judge your handwriting.
Oh, it's all good, dude. I don't use const, so you can judge me all you want. Yeah. So over here, so it's important to remember this edge and this edge is the Pacific, and then over here, from here, why is this so much thicker than the other one? This one is the Atlantic, right? Atlantic. So exactly. And so the question is asking us. So if you look in the solution, right? So the reason why. So let's figure out why these are the answers, right? So this 5, this 6, this 7, this 5, this 4, this 4, and this 5 are the answer, right? So if we look at 5, this one's pretty evident why. It's because it shares a side with the Pacific, and it shares a side with the Atlantic. So by definition, water here flows into the Pacific and into the Atlantic. Does that make sense?
Mm-hmm.
And then for 4, right? So for this one right here, that one, it already flows into the Atlantic because it's already on this edge with the Atlantic. So it's already on this edge. And water here would flow to here, and then it'd flow to here. And now this one right here shares the edge with the Pacific border. So then that's why that one is, right? So those are important to understand, why these are the answers first. So let's go to one that's a little bit more trickier. I guess 5 isn't too tricky. But, so this middle one right here, if you look to the right, it flows downwards into the Atlantic. If you look right here, it flows downward to the Atlantic here. If you look here, it flows downwards into the Pacific. If you look right here, it flows downward into the Pacific as well. So, and then 7, 6, and 5, those ones are also pretty self-evident. But so the question is here, which techniques do we know that we can use to find this solution, right? So what I did first was I did a DFS solution, and pretty much what I did was I went through every single node, and basically I I went downhill. So like right here, right? So there's 5 here. I would look to the left. Or actually, let's start with a better one. So let's say like I'm already in my loop, right? And I'm looking at this one right here, this 3. So basically, I had 2 DFS solutions going on at the same time, and one of those DFS solutions was looking for the Pacific, and the other DFS solution was looking for the Atlantic. And when you're doing these, you're basically looking up, down, left, and right for both of them. And you also need some type of function called like isValid, where you put in an x and a y coordinate in your matrix.
Yeah, check the boundary.
Yeah, so it returns like some boolean that's false or true to say it's just a valid move, right? Because if it's not a valid move, then you can't do it. You're basically outside of the border.
Yeah.
And so basically, so one of the DFS solution, let's say we're doing Pacific first, it would look at all of the numbers that are lower around it or equal to. So it would notice this number and it would notice this number. And we knew that it met the Pacific Ocean when the row was equal to 0 or the column was equal to 0, right? So this one is for Pacific. And we knew that it hits the Atlantic Ocean if the column equals to matrix of 0 dot length minus 1, or the row was equal to matrix dot length minus 1. Does that make sense?
Yep.
Gotcha. Cool. So let's reiterate that real quickly. So we have 2 different DFS solutions, one for Pacific and one for Atlantic, looking to see if we get to these borders, right? And if we can't, so basically like the DFS solution, right, would look like let's call it DFS. Oh my gosh, we'll call it DFS Pacific, and we'll do and DFS Atlantic. And then these are the functions, right? So you pass in like x, y, and y into them.
Right.
And pretty much is looking for downhill. And for all purposes, this works. But it's just super inefficient because you're going through every single possible. So what is it? So this matrix is n by n, right? So m by n. So you're going through all of these, but each time as well, you're doing 2 recursive functions, which themselves could also go through every single square again, right? So this would be m times n times n times n, which is just, what is that, m squared n squared, which is just terrible. It's a terrible.
Quad.
Yeah, it's a terrible time complexity, right? So I was like, okay, there has to be a better way to do this because this isn't efficient, and I'm pretty sure if we put this like in an interview, they like let it slide because sometimes it's better to find the answer instead of not finding an answer at all. But the better way to do this is
Wait,
to.
hold on, I'm sorry.
What's up?
Before you reveal the better approach,
Yeah, go for it.
I'm a little confused on one thing. So like the first approach was to have DFS Pacific and DFS Atlantic, right? And it's that time complexity because we go through every single node.
Exactly.
And in DFS Pacific, we're checking if any of the nodes that we plug into can eventually reach row 0 or column 0.
Yeah,
right?
row 0 or column 0 for Pacific, and last column or last row for
Right.
Yeah, for
so
Atlantic.
Wouldn't that mean like let's say oh crap, I can't draw. But we need to start a jam session. Damn it. We will hang out.
I wonder if I can invite you to this. Oh, I can have a web link. Hold up, I can create a web link, and I think you can actually. Look at this. There you go. I'm gonna send this to you on Slack real quick. Yeah. Hopefully that works out for you. I've never done this before, so I have like no idea if that works out. Oh, that definitely sounds like a Microsoft thing to do.
Okay, I'll create one really quick. Give me like 1 minute.
Yeah. I'm gonna clean this up because I really don't like how thick this line is. It's bugging me. Yeah, this pen does come in handy though, so it's kind of nice. Let's see. Oh yeah, that's so much better. It is at Atlantic. Yeah, squiggly line. I think I can also like lasso this. Can I lasso this? No way. Oh, I can lasso that.
What's lasso?
Oh wow. I can lasso is pretty much where like you circle something like this. It's something they have in Photoshop, and then you can just like drag it and move it somewhere else.
Oh.
Yeah, it's kind of useful.
So I'm trying to create. I had a forget it. It's just too much trouble. But okay, I'll give you the coordinates. How about that?
Yeah.
So my question was that at coordinate y 1 1, right? Row 1, column 1. That's a 2, right?
Yeah.
So technically, that is a node that could reach Pacific Edge.
Yes,
right?
this one could reach Pacific Edge by going this way. Yeah.
And so can row 1, column 2.
Row 1, column. Row 1. Oh, column. 2. So this one.
The 3 to the right of it.
Oh, this one. This one, right?
That one can too, right?
Yeah, this can flows into the Pacific, yes.
Yeah, and so can row 0, column 0, row 0, column 1, row 0, column 2.
Yeah, so these all can flow into the Pacific, yes.
So, and that's not the right answer we want.
Yes, that's not the right answer. And the reason why is because the question wants us to say if it rolls into the Pacific and into the Atlantic. So if a water droplet were... So let me grab another color. So if a water droplet were to drop from here, or to... Oh my god, I'm using the wrong side. Were to fall here, could it roll downhill into both of these, right? And from this spot, it can't.
Right, got it. Okay, all right, I'm clear now.
Gotcha, cool. So, yeah, so we'll continue to go with their approach, right? Let me see if I can move this stuff because I kind of want some more space to play around with. Can I grab that? I can. Okay, I'm going to put you over here. Okay, I think I can also make it smaller. Anyways, so right now, the approach we're going with is we're starting at a height, and we're only traversing with depth first search, going left, right, down, and up, if we're in bounds, and if the next height is equal to or smaller than our current height, right? So okay, I'll write that out just to make it a little bit easier. So right now, we only do DFS. You DFS to left or right or up or down if the left, right, up or down height is less than or equal to our current height, right?
For example?
So for example, like let's say right here, we're looking right in the middle, right? So this is row equals 2, column equals 2. The height here is 5, right? And we're looking at these 3 possible ones. And we realize that every single one of these is less than or equal to 5, right? So 3 is less than 5, 4 is less than 5, so on and so forth. So we know we can do a DFS on up, down, left, and right from that location. Right? Does that make sense?
Yeah, because we're trying to find a node that can make it to Pacific top left and Atlantic right bottom.
Exactly. So and that's what so we can, like I said before, we can do this exact approach from any one of these points and see if do two different DFS solutions and see if it flows into the Pacific or into the Atlantic, which is totally fine. But there's a better way to look at this. And I guess the first question I ask is, what's the opposite of going downhill?
Going up.
Exactly, right? And if we wanted to go uphill, would we need to start anywhere else? Like, would we ever need to look at the middle? Like, for example, if we were doing uphill, right, instead of downhill, would we ever have to start at any one of these nodes in the middle? Like, start a DFS solution at this 2, 3, 4, or this ones, or these ones. Would we ever have to start?
We would just look at see if we're on the edge, and we will make it.
Exactly. So that's exactly the approach we're gonna go with, right? So we're gonna have so now instead of having two DFS solutions or two DFS functions, we're gonna have one DFS function now, right? And this is gonna take an X, a Y, or in this instance what we're going with, it's gonna take matrix, it's gonna take row, it's gonna take column, and it's going to take a memo, right? And now for memo, we have two different memos. We have the Pacific memo, and we have the Atlantic memo. And pretty much what we're doing here is let's say we're going to start with the Pacific Ocean, right? So for when we're doing the Pacific Ocean, we're going to look at these points only. Let me circle them. So when we're doing the DFS, we're looking at these points only. So 5, 6, 2, 3, 1, 2, 2, 3, 5. And we basically have two things that we're going to say. We're going to say if matrix of row and column does not equal to true. And I'll explain this in a second. Then we do DFS of matrix, row, call, and go back.
Did you mean memo?
Pacific memo.
Did you mean to put memo inside if or?
Oh, right here? Oh, yes, I did. Sorry, I meant to say memo. You're right. I put matrix though. So we put memo here. Thanks for catching that. So we put memo here. Or memo. Sorry, this should be like Pacific memo.
Oh, right.
Yeah. So the way this is gonna work, right? So I'll start from the top. We have two different memos going on. We have Atlantic memo and we have Pacific memo, right? And pretty much what we're trying to do from any one of these points over here. So either we start at this 1, or we start at this 5, or start down here at this 6. We're trying to see how far uphill can we go. I like to call this part attacking from the ocean. Because pretty much what we're trying to do is we're trying to see how far we can roll uphill. Or how far we can like push uphill, right? Until, there's no more uphill to go. So for example, right, let's start off at this one up here. Let me change my pen. I'll change it back to blue. So from this one up here, remember, we're going to check left, up, down, and right. So if I look down, so let's say we start with down first. I can go to here, and then from this 3, I look left, right, and down, and I realize that, well, going 2 would be going downhill, and going from 3 to this 2 right here, these can't happen. Because now, instead of us going downhill, we're going uphill instead, right? Does that make sense?
You mean the other way around? Instead of we're going uphill, we're going downhill?
No. We are going uphill now in this instance because, so if we were to iterate through every one of these points, right?
Yeah.
Then in that instance, we would be looking for our water to go downhill. But since we are attacking from the ocean, because we know that any of these points in this green rectangular box, these all start on the Pacific Ocean. So we know that these points start there, and as far, and like if they roll uphill, then we know every point we touch rolling uphill flows into the Pacific Ocean.
Right.
Yeah, so let's just start with this one here, right? So we know this one goes to here, this one goes to here, goes to here, it goes to here. From this 2, it can go to 2. It can go to here, it can go to here, it can go to here, it can go to there. It can go up here. Yeah, so we're going uphill right now. We're going uphill. So we're looking for which neighbor has a higher number or equal to our current number. So this goes here, goes here.
So we're trying to look for, so like if we start at 0, 0, right? Top left corner. Right?
Yeah. Let's start there again.
So we start at top left corner. We're trying to look for surrounding waters that could flow towards the Pacific boundary, right? Because right now we're just checking for inside Pacific Memo.
Right? Yeah, right now we only care about the Pacific Memo. Yes.
Okay, so all I care is that any of the waters that's not contained inside the green lines that you drew, which is the Pacific, which is the first row and then the first column, right? So 1, 2, 2, 3, 5. That's the first row.
Mm-hmm.
And the first column 1, 3, 2, 6, 5, right?
Yeah.
So we're basically trying to look for waters that could flow into whatever's inside a green container and hit the boundary.
So right now we know for a fact if we're starting at any one of these numbers in this green rectangle that they're for sure already rolling into the Pacific Ocean, right?
Sorry, I forgot. We're supposed to look for waters that can go from Pacific to Atlantic.
So yeah, we're looking for points. If we were to drop, so like for example again, if we were to drop water in this 5, oh god, such an ugly pen.
Can I fire up the whiteboard jam, because this is so frustrating for me not able to draw. Sorry about that.
I just have to redraw some stuff, but yeah, sure.
It's okay. It's okay. Oh, I see.
Yeah, I don't know if this link works. Anyway,
it doesn't. Microsoft is it's giving me trouble with signing up stuff. So okay, let's just keep it simple, right? Like, the objective is to find as many coordinates, XY coordinates, that can flow from Pacific to Atlantic. That's it, right?
No, we're trying to find a height where water. So if I drop water here at this 5 in the middle, right? Water from this 5 would flow into the Pacific and it would flow into the Atlantic. So we're looking for heights where if you drop water on it, it flows into both the oceans at the same exact time.
Oh.
Yeah. Does that make sense?
Okay. Yes, that makes sense.
Yeah.
Sorry, I keep forgetting.
Oh yeah, you're good.
Then once we have the numbers inside the green container, right? So now what?
Okay, so now what is, so we know all these numbers in the green border or in the green rectangle. We know all of these already flow into the Pacific Ocean, right? If water were to be here. So now what we're doing is we are trying to see how far or which heights next to these numbers, like let's say this 2 right here, which heights next to here are greater than 2, right? Because if we basically do the opposite, instead of us going downhill, we now go uphill, then once we find the farthest point we can go to, the water would flow from that top height down into the Pacific Ocean, right?
Got it.
Yeah, so this 2, for example, let's say...
Or the same, right? If it, because like the same would work too, because earlier you pointed out that if they're the same height, the water could roll either direction.
Exactly, yeah. So like for right here, this 2, the water, let's see, or let's say this 2 over here that I'm pointing at, water would flow to this one and to this one because they're the same height.
Mm-hmm.
Yeah. So what I'm trying to get at here, right, is we're having 2 different DFS functions. One, we're using the Pacific Memo, and one, we're using the Atlantic Memo, right? And as we're doing our DFS solution, we are putting into our memo T.
Hold on.
Oh.
Someone joined.
Hi.
Oh, hi, Cap.
Hi.
Hi, Cap. Oh,
Do you want me to mute?
Oh, you're good. Don't worry about it. So back to this, right? So now you understand, hopefully, that our goal from starting on these points on this border is to see how far up we can go uphill. Now.
Right.
So I'm just gonna let me just. So what is this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just gonna do this real quickly.
Can I ask a question real quick?
Yeah, go for it.
So for Pacific Memo, right? Right now we're gonna start from row 0, column 0, and we're gonna try to work our way uphill and see how far we can go up, right? And my question is, where should we stop? Should we stop at the diagonal line? Because we still have a Atlantic Memo, which would be, I imagine, is the second half of the Dfs search, and then we just find coordinates that overlap.
Yeah, I see what you're saying there. No, I see what you're saying there. Let's go through this real quickly, and then it'll make more sense.
Okay.
I think. So I'm just gonna. Oh my God, can I not do that? Wait. Okay. Anyways, so pretty much, right? We have. So as you remember, we have 2 different memos. One for Atlantic and one for Pacific, right? And what we're doing is, so this one right here, this one is the Pacific Memo. And let's start, so we're going through this first row. So 1, 2, 2, 3, and 5. Let's start this 1 real quickly, right? So this 1, we know we can get to that 1, so we put true. Let's go down, right? 3 is greater than 1, so we can go there. We put true. And from 3, we can't go to 2 or 5 because those are now less than our current number. So now we're done doing a Dfs solution this way. And now we go back to 1, and now we look to the right. So 1 is less than 2, so that's true. We can roll uphill. From this 2, we'll go down. 2, we can go down again. 2, we can go down again. And now from here, we can't go left, down, or right. So we go back to 4. And from 4, we can go to 5. And then from this 5, we can't go anywhere. So we go back, we go up. And from this 2, we can go to 3. Then we go to 4. And we go to 4. And we're done there. So now we go to back all the way over here to this 2. And now we go to the right. So we can go to this one. We can go to this one. And we can go to this one. So this is after us just going to 0, 0. Does that make sense?
Yep.
Okay, gotcha. And from here, we technically don't need to look at any more things in the first row, right? Because we already went through them when we were doing the DFS solution from the first one. So the first row is done. We no longer need to look at that row.
Right.
So now we can go down. Let's look at this bluish 3, right? So from this bluish 3, we know it's true because it touches the Atlantic Ocean or the Pacific Ocean. But we also know that there's no more upward to go from there. So we go into the next one. So now we're at, did I miss?
Wait.
Oh, no, I think, I messed up. Yeah, I messed up.
Yeah.
Yeah. So we already looked at 3. Yeah, so we're looking at the 2. My bad. So 2 right here. So we do true. We don't go to the right because we already saw that. So we go to the 6. That's true. And then it goes to the 7, but 7, we already did that. So we're done there. And now we're at this last 5. And now 5 is true. And we can't go uphill from here because all the numbers next to it. Well, 6, we can go to 6, but 6 is already traveled to. So right now, this is what our memo looks like. Does that make sense?
The only confusing part for me is that, so if we look at the column 0, right?
0 columns, row 0, column 0.
No, sorry. Row 0, column 2. Sorry.
You're good.
Row 2, 0, 1. Row 2, column 0.
So
2 on the.
So this 2 right here.
Yeah.
Okay.
So in the memo, right, it's a true for that position, but that wasn't true when we first went through our Pacific memo, right? It didn't turn true until
we iterated to it.
Yeah, until we went to it, because first time it wasn't true because we were trying to look for ways to come uphill, and then the second time we went to that same position, it became true because it's on the edge.
Yes.
So wouldn't that be confusing to memorize?
No, and the reason why is because, so remember when we started from that 1 from the top up here and then we went to this 3, this 3 is now looking for numbers that are larger than it around it, right?
Right.
So that's why we couldn't go to this 2 or 2. But when we actually got to this 2 by, iterating through this first column, now we can make this true because we know this height flows into the Pacific Ocean. And now we can start looking at its neighbors to see which numbers are bigger than it.
Okay, that makes sense.
Mm-hmm.
Convinced.
Exactly. So that's the Pacific Ocean. Then everything else over here in this memo is false, but we'll just keep it like that for now. So now let's do something very similar to this. So 1, 2, 3, 4, 5. Hopefully I did that right. 1, 2, 3, 4. I'm probably gonna make. Oh, there you go. 5. Yeah, I think I can also scroll down a little bit just to make it easier.
No,
What's up?
no, I'm good. We can continue.
Gotcha. So then now we're basically doing the same thing again, but now we're looking at numbers within this yellow squiggly cylinder rectangle, right? And now we have something called the Atlantic Memo. And just so we're all on the same page, everything within this yellow rectangle or this yellow cylinder L shape, all these points for sure flow into the Atlantic Ocean because they're on this Atlantic border, right? So that's important to note out. And we're going to do exactly what we did for the Pacific memo, and now we're going to do it for the Atlantic memo. But we're starting from this yellow L shape instead. So let's start at this 5 at the very top, right? So we know this 5 is true. And now we're looking for numbers around it that are larger, but there's no numbers larger around it, so now we go to the 4. So the 4 is true because we know it flows into the border, and now we're looking for numbers around it that are equal to or greater than. So we can go to the left, true. So from this 4, there's nothing to go to. So we go back, and we're pretty much done there, right? Because there's no more numbers larger than it or equal to. So now we go down to this 1. So now it's true. And now this is where we can move. So we'll look to the left. We can go to 3. From 3, we can go to 5. From 5, we can't go anywhere. So we go back to 3. 3, we can go to 4. From 4, we can't go to 1. We can't go to 2, but we can go to 5. And then we're done there. Now we go to 5, but 5 is already true, so we don't worry about that. Now we go to 4, we put this to true, and 5 is already traveled to, so we don't go there, and 2 is smaller, so we don't go there. We go to 2, similar thing, we just put it as true and move on, because we can't travel to anything higher than it. And now we get to 1, so from 1, this is true. We look up, we can go there. We look to the left, we can go there. We go back down, we traverse to this 1. This 1 is true. We can go to the left, that's true. Then it goes up. And I think that's everything. Yeah. So, let me see if I can lasso this so I can move it around.
You just use both memos, look for overlapping.
Exactly. So that's all we do now. So now we have these 2 memos, and these 2 memos have true values where it flows into the Pacific, or true values where it flows into the Atlantic. So now we just have this last one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we notice that the trues are going to be here, 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 and here.
What's this last square right here? Is this a third memo or?
No, so this one. So this one I just did it for visualization purposes, but what you would do to get the solution, to get the output that they want you to have, is you just have like a I'll just
input, check and plug in both coordinates as you loop into both memos. If they're both true, then push coordinates into your result array.
Yeah, I think did this work? Kind of worked. This looks really ugly on here. But this is the code that can I change this color or something?
That looks right.
Yeah, so pretty much you iterate, right? So for var I equals I less than matrix.length. So pretty much you're going through the rows, going through the columns. And if the Pacific memo and the Atlantic memo are both true at this row and column, then you push the row and column to a result array.
Yeah.
And that's it.
How did you so when you first were going through the Pacific memo, how did you give the coordinates? Did you just grab all the coordinates on the first row?
I see what you're saying. Yeah, so what I did was I pretty much had 4 different for loops going on, right? So I had a for loop that went through, let me change this color. This is going to be a really ugly color. I had a for loop that went through here for Pacific, and then I had another for loop that went through this one. So I had 2 different for loops going through row 1 or row 0 and column 0. Mm-hmm. And then I had 2 more for loops after that going through the last column, mm-hmm. and then another one going through the last row. So, and the respectively, they change the correct memo and stuff.
Got it.
So, yeah. So let me see.
Did you try both solutions? Like first, like did you submit both solutions to leetcode?
I did, and
it was much better.
Yeah. So the first one it worked, but I was like the bottom 4% of people. And then with this one, I think I was like in the top. I forget what the percentage was. I guess it doesn't really matter because this one is a lot more efficient because you don't have to go through every single thing. But yeah, so this solution is, or this approach, because before, like, the original approach that they want you to go with is you're trying to find water that rolls down into both of these oceans. But the easier way that really helped to me was attacking from the ocean. Like, if Poseidon himself, like, if
or outside or inside out, I guess. So it depends on which way you want to look at it.
Yeah.
We attack two sides of the ocean and we overlap whatever is. We find the overlapping waters, and then, that's it.
Exactly. Like, if Poseidon himself was pushing water uphill from the Pacific and the Atlantic Ocean, that's what helps me, like, visualize this kind of stuff.
Nice.
But yeah, like, I can also let me see if I can screenshot this real quickly. So for code purposes, well, you'll see this in a second. So this is that one, and I can just move this out of the way if it's too much. And then the Dfs solution looked like this. So this is all the code I wrote for this particular problem.
Wait, the one on the right is the second implementation.
No. This is all what I submit to GitHub. Like, both of these are in the same thing. Yeah.
Gotcha.
Or GitHub, sorry, leetcode.
Okay, and attacking from north from Pacific coast. Right, so going uphill, right? Trying to find uphills. So pass in Pacific, and then if it's true, return. Otherwise, mark it true. Then we have the directions. And then if it's inbound, then new height. And if the height is greater than or equal to the height, what's the height? Oh, the height is I0. So if we are going,
because technically you don't need to pass height into there. You could just establish a variable called height that takes row and column. But I just found it easy just to pass in height. But yeah.
Wait, hold on. I'm not registering. What's the height? First for loop. What's the height again? Is this the
height is the value at row 0, index I. So that's like whatever number's in there. So like over here in the left where it says Pacific, a row column 0, 1, or row 0 column 0 is 1, right? So 1 is the height at that point.
Right. Oh, okay, got it. That's the current node.
Exactly.
Okay, and then new height would be new row, new column. Where's new row, new column? Moves 1. Can't really read that. Moves 1.